Okay, so if you remember, today we will take a look to a very interesting topic, something that I have already explained. Nevertheless, I wanted to give you some background, right, about the same, just to make sure that you feel comfortable what's going through, and to make you feel comfortable to about what it's expected for today's class. Okay, when we are talking, actually, I already mentioned cluster analysis. Does anyone remember what clustering analysis is, or what does it stand for? What is that being used for? Do you remember? Nope, no worries. If you don't remember, either way, that the main intention is to give you some background from previous classes, but either way to make sure that I can cover whatever is expected for today's class, right? So no worries about it. So actually, I was planning to use a tablet, but to improve my drawings, I'm having kind of trouble managing it. Um, anyways, I'll see later on. Okay, anyways. So when we are talking about clustering analysis, if you remember, can anybody tell me the different type of models that we have, or the two main groups that we have? Do you remember that we have models which are where you have labels, and models where you don't have labels? Do you remember the difference between one or the other, or the name or the classification for each one of them? Anyone?
Supervised and unsupervised or no?
There you go. Beautiful. Thank you, Anna. Thank you. And can anybody tell me what were the supervised models that we have seen so far? Or not all of them, just the main groups that we have seen so far. We have seen mostly two of them.
Logistic regression.
Yeah, regressions. Regressions is one, and the other one, how is it called? Because for regressions we have, and actually logistics regression belongs to the next group of models. Do you remember how are those called, or what are those being used for? Do you remember?
To know the categories, because in one you knew the
Yeah, exactly.
categories,
And,
and
and how are those models called?
I don't remember.
No worries. Those are classification models. So if you remember, for the supervised models, we mentioned that in order to use supervised models, we need to know either historical records, labels, categories, or whatever may lead us to understand what is expected for the next level, or for the next, or for the decision, right? Is where actually we went through using, for instance, for the classification models, right? First, the regressions, actually, right? That if you remember, a regression is nothing but, okay, we have a Cartesian, and in every word, we know that we have a couple of dots, right? We have some points, right, in our model. And based on that, we would like to understand the pattern and to try to anticipate which would be kind of the closest prediction for the next pattern, right? So let's say that, for instance, I'm performing a regression model. Like in this case, let's say it's on, do you remember that we have the different types of regression? Can you tell me which are the different types of regressions that we have, or mostly we covered?
It is linear
There you go.
regression.
Beautiful.
It is multinomial, and it is polynomial.
Beautiful. There you go. Exactly. And there is one last one that Samuel mentioned, which is kind of between a regression and a classification model, right? Which is a logistics regression. Nevertheless, it's more classification than regression. But it is what it is, right? Exactly. Thank you, Roberto. So that's exactly those are the kind of regression models that we took a look to. So right. So in this case, as we can see, the next prediction of or analysis can be anywhere, like in that particular, actually this is the right one. So it can be anywhere, right? In this prediction, it can be it must be something closer to the line that we have written or we have anticipated. So that's exactly the model, right? We are identifying trends, and afterward, try to anticipate what would be the closest value to reality in the future transaction. So that's a regression model. So, and as you mentioned, we have multinomial, which means we have multiple regressions, linear regressions into a single chart. We have polynomial, which is this one, which has inflections, right? Which means that I told you in this world, nothing is linear, but you need to start in a certain point, right? So in afterward, we took a look to logistics regression. In afterward, we talked about the classification models, right? So the classification model, well, we said, okay, we have categories, right? Let's say that we would like to classify based on shape. So we have triangles, right? No matter what color it is, we have triangles here. We have triangles. And maybe we like to classify circles, right? Based on shape, right? And maybe we have squares, right? We would like to classify them based on the shape and so on and so forth, right? But also we can say that we can classify them based on color in many different ways. However, we explored different ways to classify the data using different models and simply try to understand which is the best one. However, here we have labels, right? The label would be triangles. It's one label. Another label would be circles. So I already know the categories. I already know the labels. Why? Because I'm forcing my model. I'm forcing my model to classify based on what I know, on what I'm expecting to see. Correct? So that's the difference between um, linear regression or regressions and classification. However, when we are talking about clustering, which means so clustering, let's imagine again, we have where we are plotting the data or to understand how is everything behaving. And let's imagine that you have transactions. Each circle will be a different transaction and you have them there. So I'll use same color for saving some time. You have transactions here, transactions there, right? Okay, you have each and one of the dots is a transaction, depending upon the location, depending upon the size, depending upon everything, it would be the amount, the transaction. So, however, what if we assign a name? So it would be, for instance, revenue. Oh, what a color. I could have chosen something worse. Anyways, we have revenue and we have profit. And technically, here we have another dimensions, which would be customers. So each and one of these dots is nothing but a transaction by a customer, correct? What, for instance, based on this, and you would like, let's imagine that you have 3 sales consultants, and you would like to divide the different groups of customers per each and one of the sales consultants in order to push your consultants to sell them more. Crystal clear the question? Is the question crystal clear? Okay. What would you do to assign your sales consultants to the different customers that you have? I mean, it's kind of a tricky question, actually. Nope. No thoughts so far?
Sorry, can you repeat the question once more, please?
Yes. For instance, all of these dots are nothing but transactions, right? Are transactions where actually you can, it would help you to, each and one of these dots, it is a transaction from customers, right? Each and one of those dots, it's a different customer. And you would like to, you only have 3 sales consultants, right? And you would like them to approach them and sell them more and understand which is your best customer, which is your not that best customer. And you would like either way to try to understand what are their behaviors and try to sell more. So, for instance, for those who actually work in sales, can you tell me if who works in sales support? That would be the first question.
I work as a consultant, so I've made some things in sales.
Okay. So for instance, so if you're a consultant, that means that you are focused on customers where you deliver expected work, right? But you classify your customers depending upon the different categories, correct? So you won't give, I mean, you give the same service to each and one of them. Nevertheless, you are not offering the same package to all of them. Why? Because some of them are buying more and some others are buying less. And usually you treat your prime customers differently, right? So let's imagine, actually, let me change the approach. Let's imagine that these are your transactions, right? And you only have 3 sales consultants, right? Those 3 sales consultants are nothing but the people who actually are selling for your customers, and you would like them to classify based on, I don't know, let me give you an example. Actually, my tablet is not working well. I actually practiced, didn't work fine. Anyways, so let's say that you have 3 sales consultants, and you would like to divide your different customers for each and one of the consultants in order to make sure that your customers are being attended as you expect, right? Crystal clear? You
Yes.
have 3 sales consultants, you have this number of customers, and you want to divide your customers depending upon how good is your sales consultant to sell. Okay. So the first thing that we do is to classify them, don't we? And so far, how would you classify them? We don't know. So that's why, and it's when actually we will use clustering. We don't know how to classify them. We only know that we need to divide in 3 groups. Why? Because I have 3 sales consultants. So for instance, if I ask you this question, for instance, Guillermo Wild, how would you distribute these customers into your sales consultants?
Well, first, without using the ones that you already have, like a revenue and profit.
Yeah, exactly.
Without using that ones, I don't know, maybe by regions.
By regions, okay, that would be one
Might be
classification.
there, or by, we're selling them the same thing.
Yeah, why not?
Okay, so first of all, by regions, I was gonna
Regions.
say by commodity, but if we're selling the
Commodity.
same things, commodity doesn't
By here,
expect,
right?
because, and the region I think will be very important, Professor, because due to it might have a high revenue, that like the one that you mentioned there on the green. However, the profit might be less, since the logistic might be harder there to get them the product to them.
Got
So
it.
that's what I would call the by region.
Interesting. Yes, actually, it would be a good approach. And what if I tell you then that one of your sales consultant is better than the others, and there is one which is actually new? How would you divide your customers based on the skills, experience, and capability for your sales consultants? How would you do that?
On that part, I will go by the, well, by the same one, by the revenue. I mean,
The
if the
revenue.
if the customer is really important, I will actually place their maybe a guy with better experience than the other one.
That's a very good point. Actually, thank you very much for all those approaches, because that's exactly the intention of clustering. Because let's imagine that the variables that you already know is that you have all these customers who actually are creating this revenue and this profit for you, and you have 3 levels of consultants, right? One of them perhaps is better seller than the other, and the others perhaps are lower level. So what we can do here, we can classify them based on revenue and profit, right? For instance, we can create clusterings. The first cluster would be, let's say, the high level customers, which would be perhaps this group, right?
Yep.
Why?
Yeah,
Because
they get good revenue and good profit.
exactly, there you go. There you go. That's exactly the point. So as you can see here, perhaps this is the high-end customers, right? Okay. Okay. What if we, as I told you, perhaps I have another sales consultant which is actually good, but maybe focused on those that actually are not giving us enough revenue, right? But it give us enough profit, or actually, I'm sorry, enough revenue,
Good revenue and not enough profit.
not
Yeah.
enough profit, exactly.
Yeah.
And we have one last group, right? Which would be this group, which are not giving us neither that much revenue nor that much profit, correct?
Profit.
And also we have an outlier here. Why is an outlier? Because, I mean, this guy is not giving us neither revenue nor profit. Either way, it's a customer that we need to attend. So we need to decide which sales consultant it may go through, right? So this could be salesperson 1, maybe, which we are saying that this person is, well, he's good on sales, but maybe not as good as this guy, right? Salesperson 2. So now I know, based on clustering, now I can identify which customers I can focus on to prioritize and understand which ones I can send my best sales consultant. That would be person 3. That would be the first suggestion, right? I'm sorry, the first decision. Which are the groups of customers where I can send my best sales consultant? Second, which groups or which customers are the best ones, which are in the right hand side. Those in the left hand side are good, but not as good as those in the right hand side. And those here at the bottom are the ones which actually are not my priority. However, these are an opportunity because maybe they are not buying enough, because I have not given a good offer, or maybe I'm not offering a good product for them, and so on and so forth. In other words, this strategy would help me to understand my marketing campaigns, or maybe my business strategy, or maybe my sales strategy. But again, if I want to fix something, first I need to understand it, right? So clustering exactly help us with that. Help us to classify something that is not classified, because I am using a revenue and profit. And if you use it in Excel or in another tool, it would be very difficult to prioritize. Why? Because you need to apply rules, you need to apply a lot of things in order to classify them. Here with clustering, with a couple lines of code, it would help you to classify your customers depending upon how much impact it is given to your business. Crystal clear so far?
Yes.
Wonderful, wonderful. However, we also have different kinds of classifications. I'm sorry, of ways of cluster. This is one way, which is called k-means clustering. K-means, what it does, pretty much, actually, let me return back to what it was before, if I could. I think, there you go. K-means clustering uses a methodology called centroid method. The centroid method means it takes all the dots, it links all the dots in all your canvas, and tries to identify which is the closest point to the middle, right? So for instance, let me bring all the dots together. Oh my God, I hate to admit while I'm talking. Anyways, so you start connecting all the dots, right? You connect all the dots. And once that you have connected all the dots, the algorithm itself would let you know which one is the point which is closest to each and one of the dots in the entire diagram. So in other words, for each one of the models, of course, for each one of the groups, for instance, let me use one funny color here, maybe this yellow. So maybe this blue. So for instance, this one would be the middle point, or the closest point to all and each and one of the points for that particular cluster. Because this time around, I told the algorithm to choose only 3 clusters. Same happens here, right? This is perhaps the middle point for every single part of that cluster, and same here, right? So as you can see, it takes kind of the closest dot for every single and one of the dots in your transactional model to understand which one is the middle point. In that way, it takes a ratio, right? It takes a ratio and writes this circle that it's already written here, which is the blue one, the black one, and this is kind of yellow or green or something like that. I am colorblind, so I don't care. So, and it takes the closest and creates this circle, right? In other words, it lets you know, okay, all these customers within this circle has something in common. What it has in common? Well, we don't know yet, but I know that all these people who are in this circle has something in common. All these in this circle has something in common, and all this in this circle have something in common. What? Well, now we know that it's profit and revenue, right? All of these pretty much are spending alike an amount of profit and revenue that are giving in return for my company, and so on and so forth. Crystal clear about how the clustering works? Does anyone have any questions so far? Yes, go for it, Vera.
Yeah, so I do have a question and probably we'll get to that later.
Mhm.
Can you do grouping with like more than two attributes? Like say like a mix between
course.
region, revenue, and age, and then having
That's a
that
very
will be one cluster, and then having another cluster having other different attributes and so on and so on.
Actually, yes, that's a very good question. Yes, you can mix as many attributes as you may think of, and you can use as many categories as you may think of. Why? Because if you remember, this is a three-dimensional model, right? Which means that you can include more than one value, and rather than being this a regular circle, it would be sphere, right? Three-dimensional sphere, where actually you can include, perhaps you can include color based on region. However, the intention of a cluster is to classify unclassified things. You mentioned categories. When you already have a category, you already have a classification. In here, we don't. We only have profit and revenue. So we need to classify something that is not classified. Correct?
Yeah.
How can you classify revenue? Well, between $0 and $100, between $100 and $200, and so on and so forth, right? However, when you already have the transactions, and you have 2 dimensions or 3 dimensions to compare, is where actually you can use the clusters. Of course, you can include categories, because one category that I have here is customer. What if I include region? What if I color them based on region? And that may work as well. And yes, responding your question, you can do that. You can include as many dimensions as you may think of. However, the idea for clustering is to help you to classify something that is not classified, in order to help you to identify what categories you can include in order to understand your data.
Okay, yeah, makes sense. Thank you.
My pleasure. But yes, you are totally right. You can include more dimensions in order to make it kind of more understandable. Okay, there are other different ways to use clustering. Okay, there are other kinds of clustering. This is the k-means clustering. However, we have other 2 clustering models. The first one is hierarchical clustering, which hierarchical, instead of doing by centroid method, it takes hierarchies. For instance, one hierarchy would be revenue, right? So it creates one hierarchy here and another hierarchy here. And profit, we create another profit hierarchy here, another profit hierarchy here, maybe one more here and one last here. And what is going to happen? So it will classify based on the level that it can find each and one of the dots, but based on the different categories that we can combine for, or I'm sorry, the different transactions that we can combine. For instance, let's create based on the thresholds that just we established on revenue, afterward in profit here, right? And each and one of the squares created will be a hierarchical category or hierarchical cluster, right? So each and one of them will be a different category, which would help you, right, to identify the different customers that you have. But this is a different way to organize your data, right? So you may wonder, which one is better? Well, it depends upon what would be your focus. For me, for my own personal opinion, the one that I use the most is k-means. Is the previous one. This is hierarchical. However, this one is also helpful when you want to create by levels rather than focused on impact, right? For instance, here I can create more classifications, but this time around is kind of it's kind of growing kind of piece by piece, right? You are not identifying only the methods here. It's taking between 0 and 100. It's creating kind of the thresholds where you can organize your data. Is this I'm sorry, is this clustering also clear? Hey, Ayrton, do you have any questions so far?
Not so far. Thank you.
Not so far. Wonderful. Mario? Hey,
Yes, sir,
Mario
I'm
Santana, I'm
okay.
sorry.
Thank you.
Mario
Yes, sir.
Santana, I'm
Sorry.
sorry.
I was
Yeah. Beautiful. Wonderful, wonderful. Okay. And what about you, Brenda?
Can you repeat the question, please?
Is there any questions so far?
No.
Okay, got it. Got it. Okay. So, okay, let's keep continue. So there is one last way that we can use for clustering our data, which is called principal component analysis. Well, the principal component analysis mixes both of them in the sense that it uses k-means clustering, which actually will detect where is kind of the middle point for the entire population, which would be the blue point. And everywhere it uses hierarchies to separate the data. For instance, it creates one cluster here, creates another cluster here, another cluster perhaps here maybe, and it creates a maybe, I don't know, another cluster kind of right here, right? So that's the way it works. And as you can see, all of them are splitting your data depending upon the revenue and profit. However, the classification is using different statistical methods or different geographical methods for giving a name to understand how is your data segregated and help you to classify something that is not classified, right? Okay, after all the mumble jumble that I have gone through, okay, let's take a look a little bit of the theory. So for instance, here in the clustering, we can group objects that help you to identify the similarities for all those objects and help you to classify them depending upon what you are taking into consideration. As I think, as it was mentioned before, also you can include other categories such as customers, locations, and so on and so forth. And the clustering would help you to identify them in advance without actually knowing the categories. Afterward, when you include the categories, you can understand, okay, based on these categories, how are the transactions behaving? But now you know a visual classification of your data and also a classification based on statistical records that would help you to understand how is something behaving, right? So in other words, it looks for the highest level of homogeneous data and also the lowest level of heterogeneous data, right? Where actually we identify the lowest level of interclass similarities or heterogeneous data would be the outliers, where actually those do not match into the segregation that you are doing, right? Let's use one example here. For instance, here, this is a mix of two clusters, right? The first, can anybody tell me which are the two clusters being used here, or do you want me to ask randomly? Volunteers, or I ask random? Go for it, Guillermo.
We're using the k-means, the first
Beautiful.
one.
Yeah, wonderful.
And the last one that I can remember the name.
No worries. But yeah, the last one has kind of a trickier name. You can call it PCA.
Okay.
In the market, you can find it as PCA. However, it's principal component analysis. But you are right. You didn't mention hierarchical, which is good, right? So for instance, here, as you can see, those have common. It has pretty much works similarly in the sense that the k-means clustering is taking the centroid method and creating a circular group out of that. However, all of these dots kind of are in the right-hand side and the left-hand side can be considered outliers because those do not tie into that particular group. However, what if you create more groups, right? In order to include them and make them part of different classifications. Let's say that, okay, you identify here that you have all these outliers and all these outliers and all these outliers. Perhaps rather than create 3 groups, you create six groups. But again, the groups or the number of groups is totally up to you and depends on the business. So not sure whether you would like to identify your best 5 consumers and so on and so forth. It depends on the classification that you may think of. I mean, I thought about sales, right? And classify my best sales consultants based on based on revenue and profit. It may work as well. So that's why it's important to bear in mind that this cluster would help us to dig into our data, try to understand it. How is that being grouped? How is that working, right? So here I can infer a lot of things. For instance, what if these were bank transactions, right? For specific customers. Let's say that this customer 1, 2, and 3. If you want to identify fraud, which one do you think is the customer who is kind of more likely to be committing fraud? And let me give you a hint. Which one of them has more or seems to have more outliers?
The red one.
The red one, there you go. It can be either the red or the black. However, the red one has more sparse, right? Transactions that actually lead me to think that maybe this person or this customer is committing fraud. Actually, this is the most common application for clustering, fraud detection, which is because first, you create the categories using clustering, and afterward, you detect every single transaction, and if a transaction falls for this customer within the blue circle, you may say, okay, this is a regular transaction. I won't raise any alarm. However, if the transactions are falling outside of that particular circle and is repeating over and over again, it's something that we need to pay attention to. Something is not right there. So that's why clustering is so important. It would help you to identify patterns that may be kind of tricky or something that can be detected as unusual, illegal, or something like that. Crystal clear? Beautiful. Sophia, which one of these has the lowest kind of likelihood to be committing a fraud or a irregular transaction?
The green one, because
the green one. Beautiful, exactly. The one on the right hand side, right? As you can see, most of the dots or the majority of the dots are pretty much falling into that category, correct? So, okay, as you can see, that's why it's so important to use clustering. Well, so, I mean, this is already well explained that actually it's help you to group and understand patterns and identify behaviors. And also it would help you to identify, let's say, your top 10 customers or the customers that actually are more important for your organization, taking into account revenue and profit. And I don't know, you may think of many different applications of clustering. It's something that I would like to keep for your imagination. Nevertheless, it's something really powerful that you can use in your own purposes. Okay. So, however, you may wonder, okay, Fer, is there any method that can help us to identify which is kind of the best number of clusters in our data? Guess what? This algorithm also can help you to identify which is the best number of clusters that you can have. And that method is called the elbow method. Not sure whether I have it documented here. I think I had it, but not properly documented. Instead, I'll explain it. And actually, let me explain it with a code. For instance, where is the elbow method here? Actually, I'm including it here as part of the algorithm. Nevertheless, let me explain you the elbow method. The elbow method, actually, I'll use again my super powerful PowerPoint skills. The elbow method takes all the transactions, and sort them from lower to top. right? It's kind of the equivalence. So it will take every single transaction and creates a new chart. And that chart would be something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Okay. Actually, let me make it a little bit less complicated. Something like this. Right? So what does the elbow method says? Okay, guess what? So it says, okay, this would be 1 cluster, 2 clusters, 3 clusters, 4 clusters, 5 clusters, 7 clusters, 8 clusters. So in order to identify based on the elbow method, in the piece where we have kind of the most drastic inflection is the limit of clusters that we must use. So in other words, if I have here 1 cluster and here I say 2 clusters, let's say 3 clusters, 4 clusters, 5 clusters, 6 clusters, and 7 clusters. Based on this method or based on this chart, where do you identify the first or the most drastic inflection in your data? So in other words, in the place where you identify that it changes the sense of the arrow or the sense of the vector. What if go ahead.
Between cluster 5 and 6, right?
Wonderful.
Between there.
Exactly. You are perfectly right. You are perfectly right. So who said so?
Ibera.
Ibera. Thank you, Ibera. Thank you, Ibera. Wonderful. Exactly. Exactly. Here, as you can see, can you see it's quite straightforward. So in other words, in order to make it clearer, what if we create a line? So for instance, if we create a line here and identify the trend, you can see that it would go all the way down, right? However, we see an inflection in here. We see an inflection here and we see another inflection here. However, we will always take into account the most drastic inflection into the entire model. Is that crystal clear about where to identify the number of clusters that we may use, we must use? However, yeah, go for it.
I didn't understand the last minutes because my internet connection is failing. So I don't know if you can explain again the sorry, is the
elbow method?
Elbow method, yes.
Yeah. Okay. Elbow, it's properly written. Let me check. Anyways, it's not important. I think elbow. Oh, now I'm hesitating. How is elbow? I think it's correct. Yeah, it's correct. Sorry about that. Okay, yeah. So the elbow method will take all the transactions that you have above in your cluster, and it will sort them. It will sort them. So it will take the highest transaction, which would be perhaps this transaction over here, right? Maybe this is this one above. It takes the second highest transaction, maybe this one, and it would be this one, right? And so on and so forth. And it will sort them from highest to bottom, from top to bottom. Okay. So depending upon where we have in the trend, the highest change in the trend is where we need to take into account, which is the highest number of clusters that we must have based on our data. So that's why we said between 5 and 6 clusters is the area where actually we have identified that we have a drastic change. So in other words, based on this data, the software, statistically speaking, suggests you to have 5 clusters between 4, 5, or 6 clusters, because it's where actually it identifies that it has a change in the trend and suggests you that would be the healthiest amount to classify your data. Is that crystal clear?
Yes. Yes,
Sure,
thank you.
because I don't hear you kind of quite convinced.
So we have to divide the data into 5 different clusters or into 2 different clusters into the 5 hierarchy.
Good question. No, the entire data needs to be divided into the amount of clusters that the code has identified. The elbow method has identified based on
Okay.
this.
In this
So it can be-
example, we have two different inflection points, isn't it? In 7 or 6,
Yes.
I don't know.
Yes, but we
And
need to take the most drastic.
okay,
So the most drastic here, or the extreme one, is actually the one circled in orange. Because this one is not that big inflection, right? It's not a
okay,
big change of trend. This one is not that big. This one is the initial, this one is the last one. So we need to take the one that actually has the most drastic change in trend.
Professor, I'm sorry,
Yeah.
I don't understand, but every
Mhm.
trend is a different cluster?
No, a cluster is nothing but based on the data, your based on the amount of data. Let's say that this is, as I mentioned, this transaction, it's organized based on the highest to the lowest level transaction, right? This is this transaction. This one is this transaction. This one is this transaction, and so on and so forth, correct? So as you can see, all the transactions are sorted in order in order to identify the maximum transaction and the lowest transactions we would be this, correct? So after sorting the transactions, the logic or the method says where you find the highest or the most drastic inflection is where actually you identify the cluster. As you can see, the clusters are listed here, which based on the code, based on the distance of them, it says, okay, based on the distance between one or the other, these are the number of suggested clusters, maximum and minimum. However, which one is the most suggested? The one that has the most drastic inflection in the entire population of data. That's why we have chosen this, because if you can see here between, these are kind of 70 degrees, and actually the angle that it creates here is really high compared with others. That's why we have chosen this amount of clusters as the healthiest amount of clusters based on our data. Clearer now, Uriel?
Yeah. Thank
I
you.
know,
Yes.
you're welcome. I know these concepts are too complex. I know it by fact. Again, it took me years to understand this. So believe me, I feel you. I feel you all that each time you're struggling, because I went through that as well. It took me years to learn it. So I'm trying to explain it in a couple of classes, right? 8 classes are not enough to transfer all the knowledge that I have in my brain in order to make you feel that you know all you need to know in order to apply it on daily basis. It takes first the learning, afterward practice, right? So is there any other question so far about the elbow method? Anna, questions? Fabian? Questions?
No, thank you.
You're welcome. Guillermo Renzo?
Everything clear, Professor.
Wonderful. Whom else? Brenda, questions?
No. Everything is okay.
Okay, that's fine. That's fine. Go for it, Guillermo Renzo.
Professor, I actually have one question. Is there, with this model, you can identify how many clusters you need for your model, right?
Exactly.
But can you force the model to identify maybe only 2 or 3, even if it's in the first trending line?
Okay, that's a very good question. Actually, this is a suggestion.
Okay.
However, you can choose as many clusters as you may think of. You can change it upon your own desires. For instance, in this example, it is suggesting you to have 5 clusters. However, you only have 4 sales consultants. What can you do? Just readapt your model and use only 4 sales consultants. That's it. This is only kind of the best suggestion that the model gives you. However, you can adapt the model depending upon what you have on hand. And it's something I'm going to show you in a moment.
Okay, thank you. Thank you, Professor.
My pleasure. My pleasure. So for instance, what if we already take a look to our model? Actually, let me see whether here we can modify the, no, actually this one gives you, no, actually this one calculates the clusters by their own here. Because in the, yeah, this one, the WCSS helps you to pretty much uses the elbow method, the WCSS, and suggests you the clusters. This one is an automated process. However, I think if we change the centers, you can reshape the cluster. But let's take a usually I don't modify it. Why? Because I really want to use the clusters to take decisions, right? Afterward, I can revamp, but let's take a look to that. Why not? So, because in Python, which is the code where actually I regularly code, you can modify the clusters. Here, it's automatically calculated. However, you can change here the seed, and you can change the centers, and it must help you to change the number of clusters. But let's take a look, right? So what if, let's say that we would like to perform a market segmentation. What kind of market segmentation? Okay, let's take a look. Okay, in this case, we have customers, we have genre or gender. I think it's not genre, it must be gender. We have age, estimated annual income, kind of, it's a rating. And in every word, we have spending score. In other words, depending upon how often they have bought in our companies or in our stores, we provide spending score, right? So based on this, if you can see, there are too many records. Imagine to try to classify your customers, taking into account that you have 200 customers or maybe 2 million customers, right? So is where actually we use clustering. We have a huge amount of customers, and I would like to classify them. Or maybe, what do you think about it? How based on how would you classify your customers using this table? I mean, I would like to hear your thoughts.
By annual income and spending score.
There you go. Of course. But how would you do it in Excel or any other tool?
Maybe with conditionals.
Conditionals? How many?
As we need it.
Interesting. But how long would it take you?
A lot. So you will need to do like some kind of range.
Why
Probably
not?
to start dividing the spending in buckets and then the income as well. I don't know. It will take a lot.
Maybe you can take two ranges, right? One for spending score, another range for annual income. How many ranges? Or how would you decide how many ranges?
If you use a pivot table, might work as well.
Pivot, why not? And how would you mix the data and how long would it take? What are you planning to use as the pivot? And what are you planning to use for the calculations? And how are you planning to sort them or to group them?
Yeah, it will take time.
Yeah, of course. I mean, here I'm not trying to expose you, right? That the tools that you're saying are good. I mean, what I'm trying to say is that the tools that we usually use are amazing. Excel is an amazing and beautiful and outstanding tool, right? However, eventually, what if you want to make that pivot table using 1 trillion records or 1 billion records? You cannot even have it into Excel. It has its limitations, right? So that's what I'm trying to take you to, that these tools will help you to classify all these customers. It would help you to identify the customer ID depending upon what's the customer ID. It will classify the customer ID based on the annual income, the spending score. Not only that, it will take into consideration the age to create the different groups and understand how you can classify your data out of a million, trillion, quintillion, or whatever number of records you may think of, and you can classify them just by kind of seconds, right? That's why I'm trying to ask you these questions, just to make you understand that, yeah, those tools are so freaking powerful, are so powerful. Excel, it's amazing. You can do a lot of things without being an expert in programming. However, it has its limitations. And it's when actually you may think about other tools you use, and also the tools that may give you some other inputs. So let's take a look to that, right? So does anyone feel offended for my comment or for my approaches? If you do, please let me know. For me, it's important. I just want you to make you feel that I'm trying to guide you by your hand about how to do the things. And I don't mind if you let me know that you feel offended. Of course, I will offer you an apology. But generally speaking, what I'm trying to help you is to guide you through that the things, think out of the box, right? The really tricky statement or think out of the box. So this is one of the cases. Okay. So now, what are we doing here? One volunteer, or do you want me to pick someone? Up to you.
We are selecting the column 4 and 5.
Wonderful. Exactly. Why do you think that we are choosing column 4 and 5?
Because it's the most important information about the, the income that could be key PI. I don't know.
Okay, yeah, key performance indicator, of course.
Yeah.
Wonderful. Exactly. And we're taking the spending score. You're amazing. Exactly. We are, you may wonder, why do we care about age? Okay, age can be a category, but first we need to understand the behavior. And to understand the behavior, we need to rely on data, into transactions. The transactions is the matter for the decision taking. Afterward, we can think about classifications, because if we first stick to classifications, we can stick to bias and do the wrong thing over and over again. That's why these algorithms, first we need to focus on transactions. And once that we understand transactions, afterward, we can use whatever classifications you may think of, but now the sky would be the limit. Not only age, genre, or customer ID, right? That's why first we need to focus on annual income, spending score, understand those trends, understand those behaviors. And afterward that we have understood the maximum transaction, the minimum transaction, the middle point, the mean, the average, the first quartile, second quartile, and so on and so forth, we can start thinking, okay, now I understand my data. Afterward, I will use the categories or dimensions to dig even deeper. Okay, who is in this group? Oh, I can see that people who actually is between 60s and 70 years old and is male or female, or a bias, or male or female, whatever, a mix of both. And now I understand, but moreover, it would be the spending score and the annual income, and the afterward would lead me to something else to understand what's going on, right? That's exactly what I'm trying to tell you. In Excel, you would do the other way around. First, you would use the age and the gender to filter the data over to understand the transactions, wouldn't you? Or you may, or perhaps you would use ranges in Excel is almost impossible. You need to create a rule in the right-hand side and create a category. If your amount is between this and this, it will be this category, right? And so on and so forth. However, it's likely to mistakes, it's likely to too many things, manual human errors, right? What I'm trying to tell you here is also, this code would help you to avoid manual errors due to repetition. And because to take a look, when you made a mistake in a formula in Excel, it may take too long, because sometimes those formulas can be too big. Maybe you need to take a look to column by column, row by row, to see whether those are kind of those are dynamic, or maybe those are static, and so on and so forth. I mean, you may go through a lot of pain if you don't pay attention to details, right? Nevertheless, again, as I told you, it's a very, very powerful tool. Okay, with this, what we're doing, and well, as you mentioned, we are only taking the main two columns, or the columns that actually will help us to classify the data, which are the fact of our business, which are transactions, right? It will help us that based on transactions and the spending score and the annual income to identify the different groups and identify the different customers that we can offer, for instance, a discount, or we can offer specific products. We will take a look to market basket analysis that for next class, which is amazing. I love that algorithm, where actually the combination of both, you identify the market segment with this one, and afterward with market basket analysis, you specify what products to offer to each and one of the market segments to maximize your profit. Imagine the power of that. Imagine of understanding your customer. The main intention of these tools is to help you to dig into your customer's brain and understand what's going on there based on their behaviors. This is the power of these tools. Okay, now let's take a look to that. Afterward, we are taking the set seeded here. What does it mean, the set seed? Do we all remember?
To put a random sequence.
Exactly, a random sequence, exactly. And here we are saying that those are integers, right? And it's a sequence of any numbers, as you can see, but it's a list that actually is a placeholder for 6 objects, right? That it's going to store the random objects. Afterward, here we are creating an object. So it is called WCSS, which is nothing where we are going to post the number of vectors, I'm sorry, the number of clusters that the algorithm is identifying that are required. How are we planning to do that? Well, first, we will use a for cycle or a for method. The for method means it will iterate whatever we have specified within the parentheses. What it means? Okay, for I will be a number between 1 and 6, right? Whatever. It will be between 1 and 6. Afterward, it will iterate 10 times between 1 and 10. It will repeat the same process, taking random values and iterate it over and over again. It will apply the elbow method. So in other words, out of the data set, it will take random values. It will order them from maximum to minimum. And it will, but using the WCSS, oh, what a freaking horrible color. WCSS, it will take, okay, I'm taking random values, I will sort them and identify which are gonna be my elbow to understand how many clusters I need. Crystal clear? This is what we are doing here. This is what we are doing here. Also, we are saying, okay, we are gonna sum the k-means, and also for this particular, and it will apply it to this part, it will create this column, which is withins, right? It's what is it saying? So it will create between X and I, it will create the k-means. K-means, remember, is nothing but taking our data. It will take the value that the elbow detected, which is gonna be the X. The elbow out of here will be assigned, it's here, and it will be assigned to the X. It's exactly what is it doing? In other words, it says, okay, after you finish taking these random values, you will sum them. Each time it falls between 1 and 10, which is my top 10 values. I'm sorry, it will iterate 10 times, I'm sorry. It will create this object, which is the WCS. It will assign, it will repeat the number of elbows and identify those that are actually the maximum number of elbows, valid elbows that it identifies. In other words, what is it gonna do? Because this is important. For I between 1 and 10, it means it will take all the values and repeat it 10 times and understand the data. And it will perform the exact same step. It will take all the data, organize it, boom, one time. It will identify the order or each and one of the sum of those values. And afterward, it will detect which ones belong to the top elbow until it identifies the inflection. It's what is it doing here, right? However, so what is going to happen here? It's going to do this. Let's say that it will perform the first iteration. The first iteration will take this value, this value, this value, this value, this value, this value, and so on and so forth. Okay, that's the first iteration. Okay, take the first iteration, assigns that result into WCSS, and it will be included into this sum. Okay, second iteration. In the second iteration, we'll take perhaps this value, this value, this value, this value. It will identify where it found the inflection, right? And it will assign it to here. And it will repeat the same thing 10 times. Once that it has identified, guess what? I repeated this exercise 10 times, and I have identified that this is the inflection point where I found that 6 are or 5 are the right elbows or the right number of clusters that we can use. Crystal clear? I know it's confusing, right? Overall, I'm telling you, it's taking random values, performing the iteration, and try to identify this inflection value by proving and proving and proving that actually this is the right value. This is what is it doing? Repeating this 10 times to identify which is the elbow out of the entire data based on the sum of the different iterations that it does. Okay.
I have a question.
Yes, we should. Mm-hmm.
So I think what the code is doing, it's clear right now for me, but my question is why 10 times? Is it a number that you just came up, or I mean, why not 15 or 20?
Oh, that's a very good point. As more, as the better. However, 10 times is kind of a healthy, it's kind of a standard in the market that when you repeat 10 times, you're actually proving the concept without going any further. Let's say that you have 99% certainty, but if you repeat it 100 times or 1,000,000 times, you would have 99.9999999.
Okay, yeah, makes sense.
Yeah.
Thank you.
My pleasure. So for instance, this is the example. As you can see, how many clusters? Go for it, Roberto.
I have another question, Professor. What does WCSS mean?
It's oh my God, it's that's a very good question. It's the name of the algorithm, but honestly, I don't remember exactly, but it's a method. It's within cluster sum of squares. That's a very good question.
Okay.
Let me write it down here. Put it here. WCSS.
So it is like an empty measure to iterate?
Here it is. When is it filling out? Here, where actually it takes all the random values and it takes which one is the most common value, and it takes which one is the closest to the elbow. In other words, let me rephrase that. The WCS, it takes all the random values, creates this chart, right? And it iterates one, right? First iteration, and it takes all these transactions. Second iteration, maybe identifies another one. Third interaction, it identifies a new one. Fourth iteration, finds another one. Sixth iteration, the same. Seventh iteration, the same. Eighth iteration, the same ones. And 10th iteration, the same. So based on the 10 iterations, it has identified that these ones appear more than once in that iteration, right? So it identifies that it's a replication, a model that we can replicate over and over again, and it coincides or it matches each time we run it. Afterward, once that it has identified the iterations, it creates this line. Crystal clear so far?
Yeah, so we're assigning a variable, but leaving like an empty bucket for the formula
for the four. Yeah, exactly. See, here, maybe I should have explained this. Here, actually I deleted it. Oh, here, this is creating an empty placeholder. Here, the WCSS, this is an object, which is a vector. So in other words, this object will take 10 values, 10 random values, Let me put it into Excel. And it will create a vector called W. Actually, you know what? Maybe I know why it is confusing. Because here we are assigning the method and the variable the same name. I think that is confusing. That's a very good point. Yes, here we have two different types of WCSS. We have two different types of WCSS. The first one is the object, this one, which is going to be used to apply the WCSS method to identify the number of inflections that we have in our data. Yes, here is an empty vector. So in other words, it's WCSS, and it will take the first transaction, right? So the first iteration, it says, okay, 1 cluster. Second iteration, 3 clusters. Fourth iteration, 5 clusters. Seventh iteration, 7 clusters. I'm sorry, in the same iteration, my apologies. In the same iteration, 8 clusters, and so on and so forth. Next iteration, it says, okay, it's 1 cluster. It says 2 clusters. Okay, guess what? It will move these clusters and assign. We have identified a new cluster, right? And after what goes 3 clusters, 5 clusters, 7 clusters, 8 clusters, so on and so forth. Next iteration, it may be 3, 5, 6. Okay, it says, okay, guess what? We found another common cluster that can be possible based on the random values that we took, and so on and so forth. So based on this, it creates a sum and average out of this and creates this model based on the different values that it found for each and one of the iterations. So good so far?
Okay, thank you.
So in other words, this is the vector that it is creating. Let's say that this before it was a placeholder here, the WCSS vector, and once that it runs this once, creates this object. Afterward, complements with other object, performs the second run, and identifies the 2 clusters. Runs another one, identifies the 5 clusters again, right? Runs another one, sorry, and it starts filling out that vector until it has identified all the clusters that are required for that particular WCSS vector. After it creates the vector, it creates that vector that is enclosed here is the one that you can see here. But with all the values that it took randomly. It's better now? If it's not clear, please let me know. It's important. This concept, I know, is complex, but for me, I need to rephrase it as long as it is clear enough. Does anyone have any question so far? Or is it not clear yet? Anna, what do you think? Better? Maybe not 100%, but...
No, yes, but I think I have a question, but I think you're going to explain it now with the graph, so I'm going to wait.
Okay, go for it. Okay, that's fine. Ayrton, do you have any questions so far? Is it clear?
Crystal clear.
Oh, wonderful. Brenda, is it clear why do we use the elbow method and how is that being taken out of the data?
I have the same answer as Anna. I think that you're going to explain it on the chart.
Okay. That's my hope, because I don't want anyone to stay with any doubt. So, okay, if that were the case, then let me go for it. Oh, afterward, so as we mentioned, right, we created the elbow method out of the random value, and as you can see, we run it over and over again. What do you think that is it's happening? Can you see it's changing?
Iterations.
There you go. And it's taking different random values over and over, right? But can you find any common situation here? Where do you think is the elbow?
We see that the first inflection point is in the 4 clusters.
It's between 2 and 5 or 6. 5. Yeah, I may say between 2 and 6, but can you see that? That's why it takes random values to understand those patterns. But as you can see, pretty much this at the top remain pretty much stable, correct? The ones that are changing the most are between the cluster number 3 onwards, right? That's lead us to think that is between 3 or 4, or actually, I would say based on this would be 5 clusters, which is the one that repeats more often. Can you see that? Okay, that's exactly the intention of this. That's why it performs.
I have a question, Professor.
Please go for it.
So the program is taking random values and it's giving the plot?
Exactly.
Okay.
It's taking random values, creating an average out of them, sorting them between maximum and minimum, taking random values and plotting them over and over again to show you what's the trend for the entire data between maximum and minimum, to identify which is the closest or the best value for the number of clusters out of our data. Go for it, Ibera. Crystal clear, I'm sorry, before going through Ibera?
Yes, thank you.
My pleasure. Go for it, Ibera.
Yeah. So before the cluster code you have where you have the set seed. So what's the difference? I mean, that's for the random number generator, but
Exactly.
what's the difference between having the 6 as it is and in prior classes we use like 1, 2, 3?
Okay, that's a very good question, because here I just wanted to take, I don't want ranges. I just wanted to take between maximum and minimum to take 6 random values out of that using integers.
Okay.
That's what I'm saying. Just take any. I'm not establishing thresholds. When you use the dots or commas and so on and so forth,
Okay,
you're
you're
kind
setting
of
a minimum, maximum.
exactly or specific values to use. So in here, what I'm saying, I'm using just take 6 random values out of the entire data to help me to understand how is the elbow method behaving.
Okay, thank you.
My pleasure. Okay, as you can see, the WCS method, if I run it over and over again, pretty much has similar behavior. It goes from top, decreases, and suddenly between 4 and 6, it has a highest inflection. What it means, where between 4 and 6 would be our best cluster to take into account. Based on my opinion, I think it would be 5, because that's the one that goes up and down, up and down, up and down, which is, it has the most drastic change over data. As you can see, no matter how many random values, 5 always moves. Can you see that? Okay, that's why I infer that the fair amount of clusters would be 5. But here we are taking 6, so let's take a look. Now let's use the k-means clustering and apply it here. Okay, this one, again, we are seeing 29 values, right? Again, why 29 values? Because it's the random value that I want to take for the cluster. You can take more if you want, and actually suggest you to take them, but I'm taking 29. Why? Because I just woke up this morning and I wanted to have only 29 values. Afterward, we are saying, okay, we will apply the k-means method. Actually, the library that I don't see the library. Why don't I have the library? I need the CA tools library. Okay. Else it won't work. Okay. So something I'm gonna share with you. Don't worry about it. So now let's run the k-means. Okay, it ran the k-means, and what happens? It is taking the x value, which is nothing but the one that was part of the result of the sum, right? Of the random values that it took out of the sample, right? So we are saying, okay, this is x. Centers are the number of clusters that we're establishing based on this behavior. So we can change it to 5 or to 4, depending upon our own point of view. So, and we will test that. So what if we run it? Because sometimes it takes a while. And afterward, let's visualize the results. What are we going to visualize? Okay, we will plot the x, which is nothing but the limits for my thresholds, maximum and minimum value, right? Afterward, it will take the model, k-means clustering. It won't apply any lines. Why? Because I only want the clusters. It will apply a shade. A shade is nothing but it would color, it will create a different kind of transparency depending upon the differences it finds in the data. It will create a different colors for each and one of the clusters. It will assign two labels, which is nothing but the labels that are being used, like these ones, right? These are labels. Afterward, it won't create a plot chart. It will span, which means it will create the dots as part of it, and it will create the minimum. The main will be cluster of customers, which is going to be the title. Afterward, it will use the annual income for the x-axis, and it will be spending score. Okay, what if we run it? There you go. What a beauty. What a beauty. Right? So we can see here, now what is it saying? Okay. Let's take a look to the chart. Let me increase the size. Oh, it's not doing it. Oh, there you go. There you go. Now, as you can see here, how many clusters do we have?
6.
6.
6. Okay, okay. And as you can see, what if we change it to 5? Let's take a look. Let's take a look. Why do you, okay, I'm sure you're running wrong. There you go, 5, and let's run it now. How many clusters do we have?
5.
5.
Beautiful. So as you can see, the elbow method suggested us, based on the image, that 6 was a good number. However, we said it can be 4, 5, or 6, correct? So based on the thresholds, we can see that the elbow method led us to think, okay, the elbow method can be between, as it was changing, because here I can see that the most drastic inflection is 5 for me, right? Because here's almost a direct line, and here is almost horizontal. But maybe 3 can be another number, but for me, based on my experience, 5 is the best one. So, and we ran it several times, and we found that the 5, as you can see here, pretty much when it changes, it is more drastic. So we can see here on the spotty change on the other side, still is the most drastic change in the entire population. That's why I think that 5 would be the best amount of clusters based on the elbow method. And let's take a look to the data. Let's take a look to the chart and try to understand exactly what's going on here. Let's take a look. Okay, there you go. So for instance, in here, if we sum in, we can see that we have cluster 1, cluster 2, cluster 3, cluster 4, and cluster 5. Okay, in here, what is letting us to know? Actually, what if I ask any one of you about what's going on here based on the explanation? Dora, what do you think that it's going on here? Dora? Dora? Okay. Let me choose another person. Emmanuel, what do you think that it's going on here? Emmanuel? Okay. Okay. What about Gerardo?
What is happening where?
What happened here? I mean, you remember the data, and now based on what we can see here in the chart, what can you tell me about it? Okay, let me ask you straightforward questions. What do you think that is spending score?
Needs like kind of scale regarding the spending habits of people.
Exactly. So what happened here? So it sorted out and created based on the maximum and minimum value. it created the scaling, correct? If you remember, the
Yes.
scaling is between 0 and 1. It's at, or maybe between minus 60 and plus 60. It created a scale out of that. That's exactly what happened, right? So based on spending score, and same for the annual income, correct? Now,
Yes.
okay. Now you answer a question. So let me bring another person. Thank you so much. Appreciate it. Stephanie, what do you think that is each and one of the ovals that we have here?
Well, each one is a cluster, so we have 5. I just
Beautiful.
don't understand what are the numbers that are inside, but I see that
Okay.
there are few numbers outside, which I guess are the outliers.
That's a very good question. However, let me ask someone else. Thank you so much. Appreciate it. Federico, what do you think that are those numbers there? Those in the green ones.
The ID of the customer.
Beautiful. Exactly. This algorithm is taking every single customer, organizing it, and understanding the spending score, the annual income, and also is giving us first, last name, address, and so on and so forth based on the ID. So in other words, we have a lot of information out of here. So let's say that I have group 1. Which one do you think that are your best customers? Group cluster 1, cluster 2, cluster 3, cluster 4, or cluster 5?
3.
That's an interesting approach.
So,
However,
one.
The 2?
1.
would the
One.
okay, let's vote. Who says 1?
Me.
Okay, wonderful. Who may it was you, Federico, or
Me.
Yeah. But
yeah,
was me, but
so let me go. Uriel, right? Uriel, which one?
Yes.
1?
The 1. I say the
Ibera,
1.
beautiful. Ibera,
Number 1.
okay. Rafael Gomez,
Number 1.
Fabian,
Number 1 as well.
okay. It's too biased. It's too biased. What about Dora? Okay.
I'm gonna say that this is number 5.
The number 5.
I agree. Also number 5.
Wow. Okay. Now I would like to hear from one of those who actually say number 1, why? Why do you think that group, that cluster 1 is the one? Fabian, go for it.
Yes, because maybe in average they have a lower annual income, but they have a higher spending score, which means that that income they are spending it on my products.
That's an amazing answer. You are totally right. And just for the sake of the doubt, for those, because believe me, sometimes there's no straight, pure, perfect answer, because sometimes you may need to decide not only between 1 or 2 clusters. Sometimes you may need to decide 3 or 4 and so on and so forth, right? Here's only we're trying to understand the data. That's it. There's no right or wrong, right? Now, for those who actually said 5, cluster 5, why?
Because of the quantity of customers that are clustered in,
That's
so we are trusting on the quantity instead of the quality.
that's another very interesting approach, because here means that you have so many customers that are not neither spending that much, but they don't have that much income. However, maybe it's a lower end, actually the lower end market would be this one. And actually would be this one, I'm sorry, annual income. This would be the lower end market or income, which actually they earn less money, right, than the rest. This one is quite loyal, because you are betting for volume, which means that on despite they are not spending that much annually, they are not spending that much. Guess what? They are coming to the store over and over again and at least buying maybe a popsicle or I don't know, for giving that example, right? However, which is an interesting market to keep. Why? Because if you keep this market, what if they increase their income? If there's a possibility that they may increase their income, so perhaps their return as part of this particular group, the ones that actually are giving you more money per capita are those the one in the cluster number 3. I'm sorry, in the cluster number, yeah, in the cluster number 3, but per sale. That means that they are only buying perhaps once or twice, but a huge amount of money, correct? Why? I'm sorry, let me rephrase that. I'm sorry, they are earning a lot of money, but they are not spending that much. So this market, the 3-1, for me, is not attractive. For me, it's not attractive because on despite they have a lot of money, they are not spending in my store, right? Crystal clear? However, the cluster number 1, they are earning perhaps less money or similar amount of money that those that have low spending score. Nevertheless, they are spending more into my store in bigger amounts. However, as you can see, there are not so many customers, right? So maybe they are kind of the prime customers, or maybe those who have the loyalty card, things like that, in order to keep them engaged, to push them to buy more. However, those in the middle are so attractive because the volume, it's so powerful that perhaps if we sum them all, perhaps they are giving us, well, we can see that the annual, perhaps they are giving us more income than those in the high-end market. We have not strategized that yet, right? So perhaps those are the upcoming steps. Now that I have identified that customer 72, 73, 74, 122, and so on and so forth, what if I filter them over and try to understand how much income they are giving us? But actually, based on this chart, I can say that on despite there are too many, it's kind of in the middle. I mean, it's good enough to keep the company going, right? Why? Because if 30% of them do not buy anymore, yet they are still keeping us in a safe point where are receiving a really good income due to the volume, because they are loyal. They are coming and coming and coming, right? However, if we lose one of these high-end market, that means that by one sale, we are losing a lot of money. If we lose one of these customers, it would affect us too much because each one of them are giving a huge amount of money to our companies and so on and so forth. Is there any observation out of this that you may think of?
Yeah, Professor, I think that for me, the cluster number 3
the 3
would be the one with the highest potential because they have the highest income and they are not spending a lot. So maybe you can do something to influence the demand, try to incentivize them to improve the consumption.
You know what? I totally agree with you. I mean, these ones, so far, up to this point, the cluster number 1 and cluster number 5 are loyal somehow, right? However, the potential market in order to increase or real income or real revenue is cluster number 3. What are we planning to do in order to make our customer 170, our customer 198, our customer 196 to buy more from more stores, which actually have the potential based on the income? Amazing. Exactly. This is what I was expecting from you, all of you, to identify that I may have some bias information, some potential information. However, I'm hiding some information for you. But exactly, this group is the one that you need to focus on in order to increase the exposure of the products, maybe advertisement, maybe offer them a discount, or maybe offer them a loyalty program that perhaps if they buy 2 times as much, you may give them, I don't know, maybe a discount or maybe product for free, or I don't know. You may think of the creativity is on your side. Again, I told you, these tools would help you to understand your data, understand where to focus on, understand patterns, understand your strategy. However, the one that it's going to shape your strategy, the upcoming steps, or what is coming next are yourselves, based on the experience, based on your knowledge, because I may think of something. Nevertheless, I'm an expert on coding. I'm an expert on data science. I'm an expert on machine learning, artificial intelligence, so on and so forth. But at the end of the day, Stephanie, you may tell me, you know what, Fer? I want to share this information with the marketing team and ask them to reach out to these customers and increase the advertisement for them, reach them out one by phone and ask them what do they think about the product, whether what we can do in order to improve our customer service and so on and so forth, right? Perhaps these ones are customer service only, and that's the reason why they haven't purchased more, or maybe they didn't like the product. I mean, we need to identify what's the root cause of why exactly. You made a great point. I loved it. Why this group 3 is not here within group 1. So in other words, I want to disappear, or maybe let me rephrase that. I want to move this group 3, all of them, into group 1. I want to move group 5 in the position of group between group 3 and group 1, and I want group 4 to move forward, and so on and so forth. In other words, I want them to move to the top right corner, to all of them. What am I planning to do? Well, I need to strategize, right? First, focused on imperative and urgency, afterward on importance, afterward on urgency, and last but not least, neither important nor urgent, and so on. Is there any other comment or any other takeaway or something that you would like to rephrase or correct that I have said? Because it's fine. At the end of the day, I'm telling you how to use the code and how to analyze it and use it. Nevertheless, at the end of the day, you can analyze your business upon your bias and upon your desires. Anna, go for it.
Thank you. I'm guessing that like maybe it's not part of the class, but like after
course it
you
is.
okay, when you thank you. When you get to this point and you evaluate what cluster, like Samuel said, you want to focus on your strategies, whatever. I'm guessing like the next point, the next part of coding is to actually get that list of like I want to focus on cluster number 3. So like there's a function or whatever that gives me those clients, and then I move on with other, right? With other, okay.
Beautiful. What if you take this group 3 and afterward use them for performing a regression?
Exactly. Okay.
A polynomial regression to understand how much income are they giving you and what can you do if you change your strategy. How is that changing over the period? How much it can change over periods performing a regression? Which means if you perform nonlinear regression, first start with linear, right? Or what if you take them all and perform a multilinear regression and identify which one of them has the most potential to turn it into a customer, right? And afterward, you perform a classification, classify them based on that, and create different, let's say, campaigns or different packages for each one of them in order to increase the impact for them or the loyalty and so on and so forth. That's an amazing thought. Exactly, Anna. That's an imitation.
Sorry.
No, please.
Thank you. So, but that would be my new data set, like the cluster number 3, or
yes,
not necessarily. Okay.
Exactly. You create a subset.
Okay,
of data out of this particular group, and you can start performing order of the now you have the category, right? Because now you know the name of the customers, the number of the customers, and what are their category, which would be the high-end market, right? Because the high-end but low income market, I'm sorry, the low revenue that it's giving you, better said, right? So in other words, they have potential. So you have identified them, you have classified them, and now that you have the classification, you can perform either I don't know, any other kind of classification to identify this group and this group and this group and this group, and perhaps reach them out, understand behaviors, offer them different products, perform linear regression, perform multilinear regression, and understand based on your strategy, how is everything changing based on how you're changing the different variables in your entire business.
Perfect.
So,
thank you.
As you can see, every single model that I have showed you is to provide you an in kind of integral or a solution, integral solution to provide you the overall strategy, focusing in the first in general to specific, after we're fixing the specific and going to general. That's the idea of these kind of strategies. But first, relies on understanding your data.
Sure. Do you think it's possible to perform an example of the subset that you mentioned before? For
That's it.
example,
What if I think it would be a great idea? Nevertheless, I think we don't have enough time to do it today.
okay,
Maybe I can create a video and share it with you, but it's not the focus for today's class. I mean, I
yes,
would like to
I would
focus
like
on the
it.
topic. Yeah, yeah, certainly. Let me create a
Yes.
video and share it with you. But now let's focus on the next topic because there's still another clustering that I would like to cover with you, which is principal component. So as per only having 52 minutes to explain it, I think we don't have enough time. So what if we take 10 minutes break and let's return by 19 past 8 so we can continue with the next topic. Let me start recording. And please, I would appreciate if someone reminds me to record again because my memory is focused on the topics and sometimes forget the little details of this one. So
Recording
enjoy your
stopped.
recess. I see you in a moment. Thank you so much. So let's continue with the cadence of the class. Okay. So as you can see, actually, if we take a look deeper, right? Let's identify a couple of customers, like for instance, 141, 193, and 195. Let's take a look. There you go. Let's sort it. Actually, it's already sorted. 193 and 195. So as we can see, exactly as we anticipated, that 193, well, it's 33 years old. The annual income is $113,000, and the spending score is 8, right? Which, as we can see, kind of visually speaking, we can see that it's a low score, right? So, however, we have identified the customer by itself. So we can say that perhaps we can offer something, I don't know, like important for that particular gender or something important in general, something in another product based on the historical purchasing records and try to identify based on market basket analysis what else we can offer to that person. We have not taken a look to market basket analysis yet. It will be part of the next class, but just want to give you a little clue about what is coming, right? Because the idea here is to show you the entire spectrum end to end, what you can proceed in order to improve your business using the different approaches. Okay, now I told you that we will use a different cluster. So let's remove all these. And it doesn't matter. So we will take a look to another type of cluster, which is principal component analysis. And you'll identify the difference between one or the other in a visual point of view. So actually, I won't explain some of the stuff that is going on here because you are aware of it. I'll focus only to the particular piece that it's important for you and that I would like to elaborate. For instance, you already know what it's seated here. Split ratio, actually split ratio is too high. How much we said that it would be healthy?
40.
There you go. You know the stuff. You know the stuff. Beautiful. So you now are becoming experts in machine learning and in prediction and data science, which is so good. So here we are creating the training and test set and performing feature scaling. So let's do that. We're creating this scale, which is actually being used for plotting our data. Afterward, we will use a library called Carré, where actually the Carré is where that contains some of the plots that we were planning to use, which is a different library that we haven't used. So this one contains a different types of plots that will be used as part of this plotting process. So we will use another library, which is called E1071, which actually contains this clustering algorithm that will help us to predict. So now, from now onwards, it's important to pay attention because this is something quite different that we have seen so far. Well, at least a different method. So for instance, here we are creating an object called PCA, which is principal component analysis, right? So we will do a preprocess. Preprocess is nothing but to take a sample and I'm sorry, to take the entire data, actually, to take the entire data, and accept the column 14 and apply the method, right? So that's exactly what we're doing here. We're saying we are using only two PCA components, again, as the clusters. For this one, there's no exactly specific method to apply. Why? Because this one does not rely into the elbow method. Actually, I suggest you to play with different components in order to understand how are the different clusters created. But based on the previous one, we can say that mainly those could be five, right? Five clusters, but it's something that we will start testing. Afterward, so this is the pre-process. In other words, it is applying the method to the entire data and creating a subset of data, but now scaled and feature scaled based on the transformations. Afterward, it will take the training set and apply the method to the training set. And afterward, we will transform the training set into what is this?
Vector.
A vector, beautiful. So we are taking the data out of the column and we are creating using the training set, we are creating a vector. Why do you think that we need a vector? If you remember this component, in order to classify it, it will use vectors rather than circles, right? So in other words, this vector is nothing but the separator that will be used for classifying our data. That's why we are invoking these vectors, that it will be based on the equal distance point among the data. Afterward, we will perform the prediction to the test set, right? First, we did it for the training, and afterward for the test set. And afterward, we will create another vector out of the test set. Why? Because first it was the training, right? And the test set will be nothing but with the real data. Let me give you an example. Let's say that the train set said, okay, this is the vector, this is the vector, and this is the vector. Maybe the test set would be something slightly different, but slightly, right? Okay, let's keep it yellow. Let's say that the test set is something like this and something like this and something, actually that one is too biased, but something like this, right? That's exactly what we're doing, where we can say that this range is healthy to say that between the training and the test set are pretty much close or alike. That's exactly what we are doing here. That's why we create different vectors, right? So let's rerun all over again, just in case I had missed. Okay, which one is undefined? Data frame. Oh, okay, here we go. There you go. The vector, the predict. There you go. So everything is good. Everything is good. Oh, this one. Okay, let me rerun this. Oh, before didn't make a mistake. So let me take everything. Okay, now it took everything. Let me clear this. And rerun, just to make sure that I'm not getting any error, because I didn't see it before. Yeah, no errors. Okay. So now I can see, now up to this point, I have taken my data set. I have identified the clusters that are going to be used. I have identified whether matching, whether between training and test set, and so on and so forth. Now I'll apply the entire model to take every single value and classify it based on the based on the vectors that I created in order to split the data. So what's going on here? I'm taking this library, which is a machine learning library. I'm creating an object called classifier. And this time around, you already know this one. Support vector machine. Actually, principal component analysis uses support vector machine to create this particular classifications. Why? If you remember, in the support vector machine, it used to use, you have your data plotted into here, right? Something like that. Just something like this. right? And we had one of those vectors here, which would be the first vector, right? And afterward, we created we extracted the data out of that particular vector, and we had this outcome, right? If you remember that. So this is the support vector machine that where actually we use this kind of separator to split the data and understand how is that being classified, right? So that's one. However, we are applying here similarly, but this time around, rather than using only one vector, we are using three, which means that we'll take this, and perhaps we'll take this in order to create three different groups in order to classify our data based on the different levels that it identifies for the different support vectors that it identifies, right? So afterward, what is it doing? It will apply the same method to the entire data. Now, let's predict the new values and afterward create our confusion matrix. Our confusion matrix, if you remember, it's nothing but the one that helps us to identify whether something was appropriately predicted or not. I mean, you can take a look to that one. What's the important thing here is to run the charts. Why? Because the charts are gonna let us to understand about how is the classification model working, which ones are the support vectors that are being used, and how those are helping us to classify our data. I mean, as per being so many dots and as per being so many transactions and as per being so many transformations, this plot may take a while. That's why, wait, I should have added pre-plotted, would have been helpful, but I didn't. So anyways, so here, what we're doing, okay, we're taking the training set and we are taking the results, first establishing the thresholds, right? X1 is nothing but the x-axis and the other one is the y-axis, but here we're calling it x1 and x2. So establishing the limits. So it takes the first column, actually, no, this is not the one. Where is that? Oh, error on plotting, no such directory. Oh, there's a problem with my memory. There you go, beautiful, I love that. I love when that happens. Let me run first the other chart to see whether it releases some memory. There you go. Let's see whether it plots. You know what? I know that's a problem with the. Maybe this one is not installed. That's the reason. Maybe that's why. It is telling me install packages. Let me take this. Let me install. I was pretty much sure that I had this one installed, but maybe it's something that I missed. May happen. Okay, let's wait until it finishes plotting or giving the error. But this error is because it says in my local directory cannot open connection. No, this is a timeout. It's a timeout. It's due to memory. Yeah. Yeah, timeout. Yeah, I need to release some memory. Let me try to close something. Okay, it should have been, it may plot in a sec. It's not giving any error. It should have finished already. Has anyone run it already?
Yes.
Okay, can you please share your screen? Did it give you kind of the dots and lines with different colors to split them? Can you please share your screen?
Yes.
There you go. I just gave you, yeah, there you go. While mine plots. Beautiful, beautiful. Thank you so much. Now you're gonna be the teacher. So yeah, you got now the power. You're the teacher now. So now that it renders as I told you, I mean it may take. So let's keep there. So for instance, if you can see here, similarly as it happened before, beautiful. Thank you so much. As similar as it happened with the previous cluster, instead of creating circles, this time around it created sections, and each one of the section is a vector. I mean, sorry, the edge between one color and the other are the vectors that you created. If you remember, we established to run some vectors based on that particular with this skill, right? So in other words, it created 3 vectors out of that. And those 3 vectors were nothing but used to split the data depending upon the different sections that it found. So vector 1 is where it starts in the number 2 and ends in the center. Second vector is the one that starts from the bottom, right? And it goes to the middle. And the third vector is the one that comes from the right-hand side and goes to the middle. I mean, this is in 2 dimensions. However, I told you this is a 3-dimensional vector, right? So afterward, it says, okay, guess what? Here I have identified that based on the different transactions, rather than creating 4 groups or 4 vectors, oh my, it happens when you run out of memory. And I don't know why it happens, but anyways, let me try to run it myself again to see whether now that I'm not sharing, it may have kind of a better behavior. Yeah, that's a problem with this algorithm, which uses a lot of memory, and it may be kind of tricky to show in front of the chart. Actually, mine is working now that I released some memory. So if you want, I can keep on sharing again. So for instance, let me, I'll stop it. Yeah, there you go. Now it's rendering. Okay, now this is interesting because here I can show you exactly what's going on. Here, first, it takes, as I told you, it creates the thresholds. Afterward, it plots, creates the grid. The grid is nothing but the square where is everything. Afterward, creates the column names, PC1, PC2. Afterward, takes all the predictions and plots them. So it takes only every single column but -3. It creates the SVM, which is the title. It creates the XLab, which is nothing PC1, and YLab PC2. Afterward, it takes every single dot in the entire transaction and creates it as numeric and starts taking, okay, where is that at? Okay, the position X1, X2, which means X and Y, right? Takes the first dot and plot it, boom. Takes the second dot, then plot it, boom, and so on and so forth. And afterward, it starts coloring based on, for instance, if it's the column is, if it's equal to 2, which is one of the grids, which is nothing but limits, it would color it in blue. The second group, which would be the other cluster between the blue and the green, it will put green, and between, and furthermore, the remaining one will be the red. So that's a way that it takes all the vectors and separates the data. So in other words, what it's going to do here is pretty much straightforward. For instance, the first vector would be here, second vector here, and the third vector here, where actually will help us to classify the data just per side using support vector machine. And this is only for the training set. Afterward, it's going to do the same for the test set, where actually it creates 2 plots. This is the second plot. I mean, this is taking like forever to plot it, but it's due to the memory in my computer. And afterward, it creates the test set and repeats the same exercise. Creates the plot, afterward creates the grid, plots everything, creates the titles, assigns the title for each and one of them, for the column names. Afterward, it takes the object, which is the prediction, and applies the classifier, which is the method that we applied, and it's going to apply to the grid set. The grid set is nothing but taking the test set, apply to the grid, which is nothing but the scale feature. So it can apply here. Afterward, it plots one by one by using all the columns minus, but the -3. And afterward creates the range, plot them, and creates the line in order to split between one color and the other. So for here, it's totally stuck. But technically, if you took a look, it should have created kind of something like this, right? But instead, it will be colored. So hopefully, once that I release some memory, and this time around, we said, okay, one side is, well, it's supposed to be red. One side is red, but you can specify as any color as you may think of, right? Afterward, oh, there you go. Finally, oh my, finally, right? So as you can see here, what is it doing? Well, the training set, this is taking the only, how many percent of values? We said 40% of values, right? testing it, I'm sorry, training it, and try to identify what's the behavior. So it takes each one of them and performs the prediction. First, it creates the blue group and performs the prediction. Okay, based on that cluster, identify that all these customers belong to that particular cluster based on income and based actually this one is using, no, this is the wine. We didn't take a look to the data set. My bad, my bad. So it's going to take a while, but let me open the data set separately because the data set is talking about a winery or are wines that actually are being sold to the market. And okay, what problem do you have? So I'm sorry, I'm running out of memory, so it would be difficult to take a look to your chart, but let me see whether I can increase the size. It says the downloaded package are in. It's a problem with the libraries. It says that, can you please scroll a little bit up and let me know which is the package that is telling you that it's not being loaded, please? Because up to this point we only can see there. But technically what is it doing? It's doing the same for the training test, and as you can see here, in order to understand whether the data was properly predicted. Why do you think that we have a blue point here in the red hand side? I'm sorry, in the green hand side, and another blue point. What do you think that it is? A wrong prediction, actually. A wrong prediction. So it's an error out of that, or it's maybe also can be an outlier. In other words, someone who actually has certain income and certain actually they belong to the same income and so on and so forth, but they did not buy the product or something else. But it's interesting to identify what happened with those dots. However, in the high-end market, it's a 100% accuracy. In the middle end market, we can see that there's an error in one prediction, but the lower end market is the one that actually is giving us the highest error. So in other words, this will help us to predict the market segmentation, or maybe to identify our customers, or identify oh, there you go. I love when I run out of memory. I think I need to buy more RAM for my laptop. But anyway, so is there any question so far about how the model works? No? Okay. Actually, I think we have still enough time to rerun my code because I forgot to show you what are the different variables that are being identified. That's why I was trying to tell you that these models are so powerful, because in this case, let's take a look to the data set. So as you can see, we have many categories. For instance, we got alcohol, malic acid, ash alkalinity, magnesium, total phenols, flavonoids, and so on and so forth. So as you can see, we have so many factors. Can you imagine to perform an analysis using Excel based on so many columns, so many factors, and so many transactions? For me, maybe you are better than me in Excel, and no doubt, but maybe it would take me a little while to understand how is this behaving, right? And try to understand what's the correlation among them. I mean, why would those be important to understand the customer segment based on the different factors, right? And what would it help us to understand? Well, imagine that each and one of them, it's a different kind of wine. So you would like to sell a specific wine to a market segment, right? Maybe you have customers in the north part of the country that perhaps they may not drink tequila as much as we may do in the center, or maybe in the south. Mostly in east, west, and center is where actually we consume the most amount of tequila. So if you're planning to sell a specific wine, you need to identify your market segment. So imagine that you have all this variety of wines, and taking into consideration the different factors, you can identify your market segment and understand whether there are what kind of wine you can offer them in order to make sure that you're successful in your sales, or how can you increase your sales based on those market trends. So that's the main intention of this particular analysis that would help you to perform market segment of your entire data And also not only that, but try to identify what other products you can offer to them, where actually you can use market basket analysis, right? To help them to identify what other things you can offer to them, or maybe a complementary product, maybe not another one, because they already stick to something, but maybe you can offer, I don't know, like pork scam, or maybe bread, or maybe grapes, I don't know, fruits, or something like that. Because based on this analysis, you can identify with market basket analysis what other products may be related to that particular product, and help them to identify what else they may be interested on that they can purchase in order to maximize your earnings. Is there any question so far? Did it work for you? I know that, I mean, for me, it's taking a while. It worked this morning, but sadly, I'm running out of memory. But it seems to be that now it's going to work. But is there any comment, suggestion? Do you find it useful? How would you use it for your own purposes? Do you find it useless? You don't like it? I don't know. Would like to hear from you. Sophie, go for it.
Thanks. Is there always like three vectors? It's like the rule to have three vectors, or you can, like the other type of classification, you can sort it as you may
Yeah.
think it better.
Yeah,
Or
actually, yes.
okay.
I'm sorry. Go ahead. I'm sorry.
Yeah. If it's only three vectors, or you can put more or less, or
yeah, you can include more. For instance, if you include more objects into your vector, that would help you to segregate more and to include more PCA components. So you can include as many vectors as you may think of. I didn't include more because the memory would have even keep on breaking. That's why I included 3, but you can include as many vectors as you may think of that may help you to segment your market, or to segment the transactions that you already have. But you can include as many vectors as you may think that may be valuable.
And you can also use the elbow method to know how many, or it's not related to this.
That's a very good question. Yes, you can use the elbow method actually. Why? I mean, the problem here, you cannot use the, actually, it's hard to use the elbow method because you have too many transactions.
Okay.
Right? So you can try using the, because which one of these transactions would have highest priority, right? Because in the previous one, if you remember, we have spending score and we had annual income, right? So we sorted out, we ordered it, we sorted out, and based on the inflections is where actually we identified how many vectors. Here, you will need to do it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times to identify, and each one of them may give you different inflections. So rather, I suggest you to use the standard of 3 vectors, and afterward, if you identify other opportunities, for instance, here, you may say, okay, you know what? I need another vector, or I need another classification. And it's where actually you include other objects here in the classification, and you can include more vectors as part of that.
Okay, thanks.
Yeah, but that's an amazing question. Actually, yes, I think there's a method, but I don't know it because I don't use support vector machine that often. Usually, most of the time, I use k-means clustering, rarely hierarchical clustering. And I have honestly, in my own personal professional life, have never used this vector principal component. Nevertheless, and perhaps I haven't identified the business cases where to use it, because as I told you before, usually when I'm trying to detect, I would like to, in my company, I'm attempting to detect fraud. I'm attempting to detect customers who actually are performing strange transactions, or customers who actually mostly focused on cybersecurity, things like that. That's why I have never used this vector before. However, you know what? I'm sorry, this type of clustering. Nevertheless, I think I'm gonna use it next time. So to see what's different compared with the data that I'm using, to use this one to see what different behavior would lead us to think. Because here I can see that also is identifying, this can be identified as outliers, which something interesting here would say this one, this guy, well, this guy is, I'm not worried about him. Yeah, maybe I would worry about this guy, and those blue ones, where actually I need to focus on or to analyze deeper, which may help me to identify perhaps a fraudulent transaction or maybe something that is out of range. So usually, it actually suggests you to use different methods or different models in order to, as a proof of concept. So if those match, then that means you are in the right path. So is there any other question so far before we close it out for the day? No, I think some of you, actually we have still 12 minutes. Some of you have questions about the final assignment, and I think I did not respond properly because for me in Canvas, those were too many questions, and for some reason it had a limit to provide the answer. So I need to take a look to that to see why in Canvas I could not include that long explanation. However, for those who actually have questions for the final assignment, you may stay for the remaining 12 minutes so I can clarify any questions you may have. Oh, there you go. Just said it's already finished. It took like half of the class to populate, but anyways, to plot. So thank you very much for those who actually do not have any questions. Have a wonderful evening. Feel free to let me know if you have any question via email. Preferable, please send me an email because there I think I can provide an extended explanation without relying of the interface of the Canvas. But I mean, if you want to do it via Canvas, that's fine. But I prefer via email, so I expect to respond to you in 24 hours. If you make it in Canvas, it depends upon whether they allow me to provide an answer. So, anyways, those are maybe valid justifications. So, for those who actually don't have any questions, have a wonderful evening. Thank you so much. For those who have questions, may stay and let's organize about how can we respond one by one. Thank you so much. Hopefully you enjoyed. Feel free to let me know your feedback. How can I make my class better? How can I can make you feel more comfortable with the knowledge? And certainly I will apply in the future. Thank you so much. Have a great evening.